welcome to our first asynchronous session. Today's lesson is going to be on operations with fractions and mixed numbers. Before we begin, let's review some definitions. Many of you are already familiar with these definitions, but they will be important when we're referring to different parts of a fraction later in the lesson. The numerator is the top part of a fraction. The denominator is the bottom number of a fraction. So in the examples that I have here, you can see that the 1, the 3, and the 5 are in the top part of the fraction, so we would refer to them as the numerator. The 2, the 4, and the 8 are in the bottom part of the fraction, and we refer to those as a denominator. All the fractions that I have listed here are called proper fractions. That is because the numerator is less than the denominator. So we can see that 1 is less than 2, and 3 is less than 4, and 5 is less than 8. On the contrary, an improper fraction is when the numerator is greater than the denominator. So for example, 3 halves, or 8 fourths, or 13 eighths. All of these numbers are larger than 1. If you take out your calculator and divide them, you'll see that 3 halves is equal to 1.5. 8 divided by 4 is equal to 2, and 13 divided by 8 is 1 point something. Right? But an improper fraction will always have it such that the number itself is larger than 1. So let's first talk about how we're going to convert mixed numbers to improper fractions. Have you seen this done in your lessons in Unit 1? So say I have the mixed number, 4 1/3. To convert this to an improper fraction, all I do is I multiply the denominator of this fraction times the whole number, so 3 times 4, and then I add the numerator, so in this case 1, to get the final total of 13. So again, that's 3 times 4 plus 1 equals 13. And then all you have to do is carry over the denominator. The denominator does not change. So whatever number's on the bottom part of the fraction here, we just leave it and carry it over. So 4 1/3 is the same as 13 over 3. So now go ahead and pause the video and try to do these two on your own. Alright, so let's take a look at the first one. 3 2/3, I'm going to multiply 3 times 3 and then add the 2 to get a total of 11. Then we just carry the denominator over and it stays the same. So 3 2/3 is the same as 11 over 3. How about negative 5 1/4? Well, I'm going to do this one the same way, and don't let the negative sign throw you off. I know this is a negative number, right? It's a negative 5 1/4. So I'm just going to leave the negative sign out in front, and I'm going to perform the operations the exact same way. So in this case, I'm going to take 4 times 5 and then add 1. And 4 times 5 plus 1 is 21, and we carry over the denominator, so we get 4. So the answer here is negative 21 over 4. How about going the other way around? Suppose we have an improper fraction and we want to convert it into a mixed number. Well, let's consider the following problem, 31 over 5. This does mean 31 divided by 5, right? That's what a fraction indicates, division. So the way that I like to think about this is we're going to ask ourselves, well, how many times does 5 go into 31? That's going to be our whole number out in front. Now the remainder that we get is going to be our numerator, and the denominator again is going to stay the same. So if we want to work this out by hand, let's go ahead and do that. I'm going to say 5, and we're going to see how many times it goes into 31. Well, 5 goes into 31 6 times. Then 6 times 5 is 30. Right? We subtract those two, and we get a remainder of 1. All right, so our answer here is, we can kind of read it off as we were going in a circle starting with the numerator. It's 6 1/5. So it went in 6 whole times with a remainder of 1, and we leave the denominator the same. So that 6 is called the quotient, right? The answer we got when we did our division. The numerator is the remainder that we got after doing the division, and the denominator was the divisor. Alright, so again, the way that I like to think about this is how many times will 5 go into 31? Well, it's 6. How much is left over? Well, 1 is left over. And then we just leave the denominator the same. Let's go ahead and take a moment to pause the video and try this problem. 53 over 6. Alright, so how many times will 6 go into 53? So I'm going to go ahead and carry out my long division, and 6 will go into 53 8 whole times. 8 times 6 is 48. 53 minus 48 is 5, leaving us a remainder of 5, so now I can go ahead and just write the mixed number. We're starting with the whole number, the quotient here. We can kind of read it off as a circle going clockwise. So we could say this is 8 and 5, 6, if you like thinking about it in the picture. 8 is the quotient, 5 was the remainder, and 6 was the divisor, our number on the bottom. So the reason we went and showed you this is so that you can work with mixed numbers, including carrying out all the operations of addition, subtraction, multiplication, and division. Alright, so when you're performing these operations, the way I prefer to do it is just convert the mixed numbers into improper fractions. Then go ahead and carry out whatever operation you need to do, add, subtract, multiply, or divide. Then if necessary, convert your answer back into a mixed number. So let's do an example. Alright. Suppose we have 3 1/2 and we want to add that to 2 1/3. My first step, alright, is going to be to convert those mixed numbers into improper fractions. So remember, 2 times 3 plus 1 is 7, and then we carry over the 2. So that's how I converted 3 1/2 into 7 halves. And then 3 times 2 plus 1 again is 7, and I carry over the 3. That stays the same. Alright, now we're going to add the fractions. But we have to remember the rule for adding fractions. Right, when we add or subtract fractions, we have to have a common denominator. And in this case, one of our denominators is 2, and the other one is 3. So we don't have a common denominator. So I'm going to have to find what we call equivalent fractions before I can add these two together. So in order to do this, I need to find a least common multiple between 2 and 3. That is, a number that 2 and 3 will both go into. And the lowest one that I can think of is 6. And that's just the result of multiplying 2 and 3. Alright, so let's take a look at the first fraction. I said that 7 halves was equivalent to 21 over 6. The reason why is because 2 times 3 is 6, and whatever you multiply the denominator by, you have to multiply the numerator by, so 7 times 3 is 21. So 21 over 6 is equivalent to 7 over 2. And equivalent is just another fancy word for meaning the same as, or equal to. Alright, so let's get an equivalent fraction for 7/3. Alright, so we know the denominator needs to be 6 because that was our least common multiple, or our lowest common denominator. So I kind of asked myself, what did I have to multiply 3 by to get it to be a 6? Well, we had to multiply it by 2. And if we multiply the denominator by 2, we have to multiply the numerator by 2 as well. So 7 times 2 gives us 14. Okay, now that I got my equivalent fractions with a common denominator, I can go ahead and carry out the addition. So in this case, right, we add the numerators, and 21 plus 14 is 35, and the denominator stays the same, which is 6. Right? We do not add or subtract the denominators when we are doing adding or subtracting of fractions. Okay, so now I look at this number 35 over 6, and I notice that it is an improper fraction. That is, the top number is larger than the bottom. So I'm going to go ahead and convert it now back into a mixed number. The way I do that is I ask myself, how many times will 6 go into 35? Well, 6 goes into 35 5 times. What's left over? Well, let's see, 6 times 5 is 30, so we got 5 left over. That's how I get the numerator of 5 here, and then we just keep the 6 the same. Alright, so let's do an example where I am multiplying with mixed numbers. So suppose I have 2 1/3 times 1 2/5. The first step again, whatever operation you're carrying out, is to change the mixed number into an improper fraction. Alright, so I changed 2 1/3 into 7/3. And then I change 1 2/5 into the improper fraction 7/5. Nice thing about doing multiplication and division is we don't need a common denominator. I can just multiply straight across. So 7 times 7 is 49 and 3 times 5 is 15. Okay, so now I notice again that we have another improper fraction. So I want to convert this back into a mixed number. So to me, I simply ask myself, how many times is 15 going to go into 49? Well, let's see, we got 15, 30, 45, wait, that was 3 times. So it looks like 15 will go into 49 3 times. And since 3 times 15 is 45, that leaves us 4 left over. We can count up 45, 46, 47, 48, 49. That leaves us a remainder of 4. So now we can write our mixed number as 3. 15 went into 49 3 whole times. We had a remainder of 4, and we leave the 15 the same on the denominator. Alright, so let's practice adding these fractions. 31 over 12 plus 5 over 12. So we are doing addition here. So the first thing I have to check is that we have a common denominator. And in this case, the common denominator is 12. So that means we don't have to convert these fractions and get equivalent fractions. They're already how we want them. We already want that denominator to be the same. Therefore, I can just leave the denominator as 12 and now add the tops. So 31 plus 35 is 36. And then finally, 36 divided by 12 goes in 3 whole times. And wait, there's no remainder. It went in exactly 3 times. So our answer is just 3. How about 7/4 plus 5/8? So I'm looking here and I notice that we don't have a common denominator here. So we're going to need to get a common denominator. So I'm thinking about what the least common multiple, the smallest number that both of these numbers will go into. And I notice that 8 will go into itself one time. And 4 will also go into itself, into 8, 2 times. So that leaves us that the least common denominator, or least common multiple, or lowest common denominator between 4 and 8 is 8. So I kind of write the bar first, and then I go ahead and write my 8 as the denominator. Now the second one, we didn't have to change at all. So I can leave the 5 in the numerator. However, the 4, I have to ask myself, what did I multiply 4 by to get to 8? And the answer is 2. So if I multiplied the denominator by 2, I have to multiply the numerator by 2 as well. And 2 times 7 is 14. Right now we can go ahead and add the numerators. So 14 and 5 is 9 over 8. And now this is an improper fraction, so I'm going to convert it to a mixed number. So 8 goes into 19 2 whole times, and then it leaves us a remainder of 3, because 2 times 8 is 16, and that's 3 away from 19. And then I leave the denominator the same. If I could reduce this fraction here, I would, but 3/8 doesn't simplify either any farther. And so finally we got the last problem, 17 divided by 9 plus 3/2. Well, again, don't have a common denominator. I can't just add them across. So I'm trying to find a number they'll both go into. And the lowest one I can think of in this case is 18. So I'm going to rewrite my equivalent fractions both having a denominator of 18. Now I ask myself, what did I have to multiply 9 by to get to 18? The answer was 2. So if I multiply the denominator by 2, I have to multiply the numerator by 2, and 17 times 2 is 34. Alright, so what did I have to multiply 2 by to get it to be 18? Well, I had to multiply by 9. Right? So if I multiply the denominator by 9, I have to multiply the numerator by 9. And 3 times 9 is 27. Okay, now I have a common denominator. So I carry that over, I leave it the same. And now I can go ahead and add 34 and 27. And 34 and 27 is 61. Well, 61 over 18 again is another improper fraction. So I'm going to convert it into a mixed number by asking myself, how many times will 18 go into 61? You may have to do some trial and error with a calculator, but you'll discover that 18 does in fact go into 61 3 whole times. 3 times 18 is 54. That leaves a remainder of 7 because 61 minus 54 is 7. Then we carry over the denominator, leave it the same as 18. So in this case we get 3 and 7/18. Doing the subtraction is similar, right? We still need a common denominator. Then we're going to get our fractions and reduce them if necessary. So in this first problem, I'm checking it, and I'm happy already because they both have a common denominator of 9. I don't have to do anything. I don't have to convert them into any other equivalent fractions. I can just go ahead and do the subtraction. So I subtract the numerators, and 17 minus 2 is 15. I leave the denominator the same. But now we got another improper fraction, which I'm going to convert into a mixed number. And 9 will go into 15 one whole time. It leaves a remainder of 6. Then I carry over the denominator of 9. But now I notice that 6 over 9 is a fraction that can be reduced further, right? Because they have, in math book, they would tell you that they have common factors. All right, so that's another word for saying they have something that will both divide them. All right, so what number can divide both 6 and 9? Well, the only one that I can think of is 3. Right? So I'm going to divide them both by 3, and 6 divided by 3 is 2, and 9 divided by 3 is 3. So this answer is 1 2/3. Well, I'd like just to subtract 37 minus 3 in example 2, but I notice that I don't have a common denominator. Alright, so I'm going to have to think about what the lowest common multiple between 16 and 2 is. Right? That is a number that will divide them both, or that they'll both go into. Excuse me. So in this case, the lowest common denominator is going to be 16. Because 16 will go into itself 1 time, and 2 will go into 16 8 times. Alright, so I don't have to change the first fraction. Right? I'm just going to leave it as 37 over 16. Now, the second one, I have to ask myself, what did I have to multiply 2 by to get to 16? Well, and the answer is 8. So if I multiply the denominator by 8, I have to multiply the numerator by 8, and I get 24. So now I can do the subtraction, since we have common denominators, and 34 minus 24 is 13. 37 minus 24 is 13. And I carry over the denominator of 16. And this fraction cannot be reduced, and it is a proper fraction. So we are done. Right? I can't change this into an improper. Since this is a proper fraction, I can't change it into a mixed number. Right? That's only for improper fractions. So let's go ahead and do this last one. 13 divided by 10. And I'm going to subtract not 1/2. Again, I'm finding the common denominator, and in this case it is 10. So if I multiply the denominator by 5, I multiply the numerator by 5. Now I can go ahead and carry out the subtraction. 13 minus 5 is 8. The denominator is 10. And then 8 over 10 is not reduced. They have common factors. There's a number that will divide them both. In this case it's 2. So if I take 8 divided by 2, I get 4. 10 divided by 2, I get 5. Let's do an example then with multiplying. So in this case, I've listed two methods. One is you can multiply straight across, then reduce. You also have the option of reducing first and then multiplying. All right, so you can, in this top example, there's nothing that I can reduce between the fractions. They're already reduced. 4 won't go into 9, and 7 doesn't go into 1, so there's no cross canceling I can do. So I just multiply straight across. Right? Don't get add and subtract and multiply and divide confused. Right? With add and subtract, you have to get a common denominator. With multiply and divide, you don't. So in this case, we're multiplying, so I'm just going to multiply straight across, and 9 times 1 is 9. Excuse me. And 7 times 4 is 28. Now I'm looking to reduce this number. So I'm trying to think if there's a number that will reduce both, sorry, excuse me. Let me redo this problem. 7 times 4, so we get, it's 28. And then I'm looking to reduce that fraction. So I'm trying to think if there's a number that will divide both 9 and 28. And let's see, if I start going through the things that divide 9, it's really only 3. And I'm asking myself, will 3 go into 28? And it won't. So this number is reduced. Now here's a perfect example when we're looking at number 2 where I want to reduce first. I want to reduce across and then multiply across. For example, I could multiply straight across and do 8 times 15. That's some big number. And then do 10, 5 times 2, and then start reducing that large number fraction. There's no problem with that. So if you don't know what to do, just do that. But I'm going to go ahead and use this opportunity to show you how, if you're good with your multiplication tables, that this makes it a little bit easier. I can say that 5, right, will go into 5 once, and 5 will go into 15 3 times. So what I'm really doing here is canceling out common factors that I have in the numerator and the denominator before I do the multiplying. That saves me from getting really large numbers. Well, look what else we have here. Well, I asked myself, will 2 go into 8? And yeah, 2 will go into itself 1 time, and it will go into 8 4 times. So that's what I mean by reduce and then multiply. Right, so in this case, now I'm just multiplying 4 times 3. A lot easier than multiplying 8 times 15 if you're doing it in your head. So 4 times 3 is 12, and 1 times 1 is 1, and 12 over 1 is just 12. Alright, so let's do the last example. How about we reduce it again? So I notice that 2 will go into itself 1 time, and 2 will go into 12 6 times. Right, now I'm going to go ahead and multiply. Right, so 7 times 6 is 42. 1 times 9 is 9. And I notice that this is an improper fraction. So I'm asking myself, how many times will 9 go into 42? Let's see, 9 times 4 is 36, 9 times 5 is 45, too much. Okay, so we know that 9 goes into 42 4 whole times. What's left over? Well, you can count. Well, 9 times 4 is 36, and to get to 42 means we have a remainder of 6. Then I carry over the denominator. And now I notice that 6/9 is not reduced all the way. I can reduce that further. Alright, so I can divide both 6 and 9 by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So your final answer is 4 2/3. And this is our last slide. Let's practice dividing fractions. Alright, so with dividing fractions, it's very similar to multiplying fractions. In fact, we turn this into a multiplication problem. We just have to do one step first. Right? Because what we do is flip the second fraction and then multiply. That is, multiply by the reciprocal. Alright, so let's take a look at this first example here. I'm going to not do anything to the first number, the 11/5. is what I'm going to do is what I'm going to change here is what I'm dividing by. So in this case we're dividing by 20 over 3, so I change that division to multiplication and then I multiply by the reciprocal. So that's what I mean here by flip the second fraction. So we're going to flip it over. So it's 3 over 20. Now I can multiply. If there were things that I could cross cancel and reduce like I was doing on the last slide, then you would do that. If not, then you can multiply straight across. I don't see anything between the denominators and the numerators that I can cross cancel or simplify. So I'm going to multiply straight across and in this case get 33 because 11 times 3 is 33 and 5 times 20 is 100. Just to make sure that's in lowest terms, I try to ask myself what can go into 33, and only 3 and 11 can. And neither 3 or 11 go into 100 evenly, so I know that this answer is reduced. Let's try example 2. So remember, I'm going to leave the 2/5 the same. I'm going to change that division into multiplication, and I'm going to take that fraction and flip it over. So whatever I'm dividing by, that's what I flip over. I don't flip over both of them. Only the second one, only what I'm dividing by is what I flip. Alright, now I can multiply straight across. So 9 times 2 is 18. And 5 times 7 is 35. And I'm asking myself if I can reduce this one. And I'm looking between 18 and 35, and I don't see anything that I can simplify. So I'm going to go ahead and leave that because it's a proper fraction, right? You can't change that into a mixed number. And then finally, let's look at our last example. So again, I leave 1/8 the same. Then I change my division into multiplication and I multiply by the reciprocal, or I flip that second fraction. So 7/2 becomes 2 over 7. In this case, if I want to cross cancel, I can because 2 and 8 have common factors. 2 will go into its own self 1 time, and 2 will go into 8 4 times. Now we have that 1 times 1 is 1, and 4 times 7 is 28. And that, of course, can't be reduced any further, so that is our final answer. Make sure that you go back into the announcements on your course page and click on the link to answer the questions that go along with this session that is called Asynchronous Session 1 Questions.